Hello everyone, welcome to this video tutorial on Go interface by Simplilearn. In this session, you will learn what an interface is and how to create an interface. After this, you will learn about empty interface. Further, you will get to know about type assertion and type switch. So hey everyone, I am Abhisar Ahuja from Simplilearn and welcome to this video on Go interface. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. Let's start with what is an interface. The key principle of an interface in Go is to provide method signatures for similar types of objects. Go does not have classes and inheritance to implement object orientation. Go has the interface and abstract type to fulfill this purpose. For example, motor vehicle can be an interface with method signature mileage. Any type which provides definition for mileage method is said to implement the motor vehicle interface. Let's learn how to create an interface. In Go, you can create an interface using the type keyword followed by the name of the interface and the keyword interface. And you can specify method signatures inside curly braces. You will get to understand the creation of interfaces with example. Let's move to Visual Studio Code and create an interface. I have opened a file and named it interface.go. Here we will just create the interface. For that, we will first type the keyword type, then the interface name. We will name it as motor vehicle and then type the keyword interface. We will start the curly braces and inside we can define method signatures. We will define mileage as a method and it would be of return type float, and we will declare another method that would be average speed and that would be of type string. Now we will see how to implement an interface in Go. To implement an interface in Go, you need to implement all the methods declared in the interface. Go interfaces are implemented implicitly. Unlike Java, you don't need to explicitly specify using the implements keyword. In the previous program, we have defined the motor vehicle interface, which has two methods, mileage and average speed, that return float64 value. Any type that implements these methods will also implement the motor vehicle interface. Now, let's look at a practical use of the interface. We will write a simple program in the Visual Studio Code that would calculate the total mileage for a person based on the individual mileage of his cars. For brevity, we have assumed that distance covered is in kilometer and fuel used will be in liters. So let's move to Visual Studio Code and start writing the program. First, we'll write package main, then we will import fmt, and now we will declare our interface that would be type, the name of the interface that is motor vehicle, and the keyword interface. We'll start the curly braces and declare our first method that would be mileage, and it has a return type float64. We have two cars owned by the person, BMW and Audi, defined by struct ints. So first we will define the struct for the car BMW and Audi. For that we will write type BMW and it is struct type. Inside the curly braces we will define distance, that would be of type float64, and that is average speed, and that would be of the type string. Now we have declared the let's declare another struct type that is OD. For that we will write type OD struct, and inside the curly braces we will define distance as the return type float64 and the fuel consumed with the same type float64. Now to implement the motor vehicle interface, we need that the PMW struct and the OD struct should implement the method mileage. For that, we will define the method mileage for both of them. First, we will declare the method mileage for BMW. For that, we'll write function BMW that would return the type as float 64, and we have to declare the method that is mileage, and inside the curly braces we will define this function that would return v dot distance divided by b dot fuel consumed. So we have declared the method mileage for BMW. Now we will declare for the type OD struct. For that we'll write function OD method name that is mileage, and it would also return float 64. So this would be small, and inside the curly braces it would also return the distance traveled by the OD, that would be a dot distance divided by the fuel consumed by OD. Now we will also define a function that would calculate total mileage, like both the mileages of BMW and OD in a month. For that we will declare a method total mileage. For that we'll write func total mileage, and the total mileage function will take a slice of motor vehicle interface as a parameter. So for that, inside the circle brackets we will pass a struct of the interface motor vehicle, and inside the curly braces first we will define a variable in which we will store the total mileage. For that we'll declare tm as the variable, and its initial value would be 0.0 as it would return the type float 64. Now we'll run our loop and pass a slice that contains both BMW and OD types to the total mileage function. The total mileage function will calculate the total mileage in the variable tm by calling the mileage method of both the corresponding types. So we will define range m, and inside the curly braces we will add up the mileage, and we will get it print out. That would be fmt dot print f total mileage per month, that is of float type, and it is in kilometer per liter, and it is stored in the value tm. Now we will define the function main. So first we will assign the values for the struct type BMW. For that we will assign the values in the variable b1. Distance would be 167.9 kilometers covered, comma, fuel consumed would be 36 liters, comma, and the average speed for BMW would be 58, and we have declared the average speed as the type string, so we will make 58 in the inverted commas. Now we will declare a variable a1 for the type OD and store the values for the type struct OD. Distance covered would be 152.9 kilometers and the fuel consumption would be 30 liters. Oh, I forgot to put the comma here. Yeah. So now we will declare a person variable who possesses both the cars and he wants to calculate the mileage of both the cars in a month. So here we will pass the slice motor vehicle and inside the curly braces we will pass both the variables p1 and a1 and call the method total mileage and pass the person variable in it. We'll save the code and run the code in the terminal. For that we'll open the new terminal and write the command go run and the file name that is interface.go. Press enter. Here we can find the output that is total mileage per month is 9.760556 km per liter. Now we have learned how to implement the Go interface. Let's move to another branch that is empty interface. When an interface has zero methods, it is called an empty interface. This is represented by interface and the curly braces. Since the empty interface has zero methods, all types implement this interface implicitly. Better understanding, we will understand the empty interface with the help of an example. We'll move to Visual Studio Code and create another file and name it as emptyinterface.go. And in this file, we would see an example how to implement an empty interface. For that, we'll write package main and import the package fmt. Now we will declare a variable I for the interface and just make the curly braces. Now we will declare a function found and pass the interface, and inside the curly braces we will find the type and the value of different types which would be implementing the empty interface. For that we'll write fmt dot printf the type equal to %t comma and the value of the type %v slash n. In function main we would declare the types which would implement the interface, that is an empty interface. For that we will write function main starting with the curly braces, and first we will declare a variable s and inside we will store a string that would be Simplilearn and call the method found and we'll pass the variable s in it. Now we will run this code. For that first we'll save the file, that is Control S, and now we'll run the command go run empty interface.go. Press enter. Here we can see that the output is type equal to string and the value stored in it is Simplilearn. Instead, the string type has implemented the empty interface. Now we can declare more types that can implement the empty interface. We will declare a variable that would be I and it would store an integer value that would be 7, and we'll pass this variable into the method found. Now we'll save the program and run the file again. Here we can find that the type equal to int and the value stored as the int type is 7. So it's clear that as many types can implement the empty interface. We'll move to the next topic, that is type assertion. Type assertion. You can find the dynamic value of an interface using the syntax I.type, where I is a variable of type interface and type is a type that implements the interface. Understand the type assertion with the help of an example. For that, we'll move to the Visual Studio Code and see the interface.go file. Here we have the average speed declared in the struct BMW. We will declare a method that would be average speed. For that, we'll write function b BMW, the method name that would be average speed, and it has the return type string that would come in front of the function name, and inside the curly braces we will define the function. It would return the value average speed. Now if we want to get the average speed of BMW printed, we won't be able to do that. We can see in the total mileage function we would print fmt dot printf m dot average speed. As the interface motor vehicle, it has only a single method, that is mileage. It can't access the average speed of the struct type BMW, so it won't be able to print the average speed. This is where type assertion comes into play. Type assertion lets us extract the value of the underlying type, that is BMW here, and then it will call the methods on the return value, that is M. In order to do that, we have to make a type assertion of the underlying type, that is BMW, of that interface. Once we are able to do this, we can extract the value and store it in a variable, and then we can call the methods on that variable, because now that variable has type and value equal to underlying type and value of the interface. For that, first we will copy this code and create a new file, type assertion.go, and paste the code in the new file. Now we will clear the function total mileage and declare a variable AU. We will extract out the value in the variable AU only. For that we will write m dot, and in the parenthesis we will write BMW. Here m is the variable at which we are making an assertion about. It would be followed by the period, and in parenthesis we will place the underlying type of that interface. The Go program does not see this parameter as BMW, it sees it as a motor vehicle interface. Now the underlying value has been extracted in the variable AU. We can call all of the methods of BMW by simply putting in the println function. First we'll declare the println function. For that we'll write fmt.printf, and we will call the average method, that is au.average speed, and now we will pass the BMW struct that would be declared in the variable b1. So we will erase this, and we don't need the slice here, and in total mileage we would be passing the b1 variable. We will save the file and run in the terminal. Here we got 58 as the output, that is we have passed average speed as a string, and that has the value 58. Now we have understood the implementation of type assertion. We will move to learn the next topic, that is type switch. In type switch, you get the dynamic type of the interface instead of the dynamic value with syntax like type assertion, that is I.type, where I is a variable of type interface and type is a type that implements the interface. Type switch is similar to creating multiple else if statements in code. We would understand this with the help of an example. For that, we will create a new file that would be type switch.go. In this type switch example, we would define an empty interface and we would declare different types that would be implementing this empty interface with the help of type switch. For that, we will write package main. We will import the fmt package. We will declare a function named like. We will write function like and pass the empty interface with the variable I. Now we will write switch I.type in the curly braces and it specifies a type switch. Switch I dot in the parenthesis type, and now we will define different case statements and compare the concrete type of I to a specific type. If any case matches, the corresponding statement will be printed. First, we will define a case that would have string as a type, and if the value matches with the type string, it would print the statement I learn at %s. For the next line, we would write /n and the variable I dot string type. We will pass different types in the function like in the function main. If any case matches, the corresponding statement would be printed. The next case would be it will have the integer type and it would print, so P would be capital. Okay. fmt period printf, and in the circle brackets we would write about the age. I am %d years old. For the next line we have inserted /n and we'll pass the variable I dot int. Now if the value doesn't matches with these cases, we would define a default print statement that would be fmt.printf. In the circle brackets we would write unknown type. Now we will come to the function main. In the function like, first we'll pass a string value that would be Simplilearn, and we'll call the like function again and pass an integer value, and we will pass an float value that would be 12.89. Now 12.89. Now we'll save the code. It's showing an error. Okay, we didn't define the curly braces here. Okay, the P is small of printf. Okay, now we'll save the file and run in the terminal. Go run type switch.go. In the output we can see that we have printed the statement I learn at Simplilearn and I am 27-year-olds and the unknown type. So we have first passed the value that is Simplilearn. It matches with the value string and it printed the statement I learn at Simplilearn. The next value we passed is int type and it matches with the case int and it printed I am 27-year-old. And next we have passed a float value and we didn't have any case for the float value, so it printed the unknown type. Now we are clear with the type switch. With that, we have come to the end of this session. I hope it was interesting and informative. If you liked it, please let us know in the comment section below, and also subscribe to our channel and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.